So I'd like to know the height at 5, just to end the graph properly. So I'll plug in S of 5. I'm trying to find out what that is. 25 minus 20. 5. Okay. 1, 2, 3, 4, 5. There. So you can draw this up a little bit further. Something about like that. Truncate it, wipe it away, and there's our picture, 5 becoming 25. That was a very basic way to draw the graph without resorting to calculus, and without computing the vertex or other features from formulas. Okay? But this problem is also pretty easy. T squared minus 4t is a fairly easy thing to deal with. So there is our picture of this function. Remember to truncate it, and we allow the proper t values in 0 to 5. Find and graph the velocity function. Okay? We need to find velocity, then we'll graph it. Find the velocity function. Well, the velocity is just the first derivative of position. So I need to take the first derivative of s. You find s prime. S prime of t is 2t minus 4, right? There is our velocity function. We'll graph it on the same picture, okay, in red, because we're traveling like really fast probably, so red dangerous. 2t minus 4. How do you graph 2t minus 4?
So you start at 0, negative 4.
Okay. Start. That's not red. I'm red-blue colorblind, so that's why it's going so badly today with these particular markers. Anyway, so negative 4 down there, that's on that line, right? Negative 4 is 0, negative 4. We go with a slope of 2, so up 2 to the right 1, up 2 to the right 1, looks like it intersects right there. And then I should be able to draw a straight line through there. It's going to hit that thing or not? I go, let me find another point here. 1, 2, 1, 1, 2, 1. No, it does not. Okay. We're okay with that being the velocity function?
Wait, how do you get the velocity function again?
I took the first derivative of s. Velocity is always first derivative of position. They told us to graph. What's this location? 5 comma what? 6?
Why does that say 5, comma 25?
That's what that is. Oh, you're right. It's not. It's not count 5. That's just stupid. All right. That happens. Thank you, Cornejo. Proper analysis there. It doesn't say to graph on the same graph, but I just figured it'd be nice. All right, now we have 3 questions in part B. That was the first part of part B. Part B was find the velocity function and graph it. Now there are 3 accompanying questions. That is, when is it? Right order here. When is the object stationary? When is the object moving to the right and moving to the left? Those are the 3 questions. When is the object? Want to say stationary first? Stationary. Moving right, moving wrong, moving left. Okay. Those 3 things we're supposed to answer now. So this will be easy. I will tell you something that will reveal the answer quite quickly. The sign, S-I-G-N, the sign of velocity tells direction of movement. Okay? The sign of the velocity tells the direction of movement. If you're going 5 miles per hour, you're moving 5 miles per hour to the right. You're going rightward in the picture. If you've got a velocity of negative 10 miles per hour, you're going 10 miles per hour to the left in the picture. If the velocity is 0, you're moving nowhere. You are stationary. Okay? That's okay with everybody? No big deal, right? Sign on the velocity tells you the direction of movement. So when is the object stationary? Well, whenever the velocity is equal to 0. We just said that, right? Whenever it's equal to 0. So I'll just find that out. 2t minus 4 equal to 0. When is that true? For what t value? 2. Right there, right? That's when the velocity reaches 0. He has stopped moving for a brief moment. Okay. So t equals 2. T equals 2 is whenever you are stationary. So that's a particular point in time. Boom. That moment right there, when you hit 2 seconds, you stop moving. Okay? What that means by stop moving is you went through a 0 velocity. So this is going to be a quick example. When you go backwards, say you drive backwards out of your driveway because you drove forwards into it, hopefully. Okay? So otherwise your garage is in big trouble. So you drive backwards out of your driveway, right? What happens is that moment where you stop and you start to go forward, right? So when we do it, it's not quite instantaneous. It's not like, and then just suddenly you go, right? There's a moment where you actually feel the stop, and you actually stop, and you start to move forward again. The way this is, though, he is going from a negative velocity, this is below the x-axis, he's going from a negative velocity, he runs through the 0 and immediately starts going forward. For him, there's no like physical stop. It's true, he passed through a velocity of 0, but it all happens so instantaneously, you would not perceive it if you saw it. Okay.
How do you start at a negative velocity?
That's just when they took the picture of it. He's going to the left at 10 miles per hour or something. Actually, you can just tell. You can tell. At 0, he's going negative 4 to the left, whatever the units are. So negative 4 to the left. Okay.
Negative 4.
Meters per second, miles per hour, whatever you want to choose.
Oh.
I don't know what that's the top of the question. Feet and
the
seconds.
To the left.
Okay.
4 lines per minute.
S in feet, T in seconds. So he's already traveling negative 4 feet per second leftward. And then you just happen to start time when you see him doing that. This would be, you know what I'm saying? This is when you started taking tabs on him, that's all. Roger.
So when it says moving left, it's the sign tells us where the velocity is going. Would we change it into 2, or is there supposed to be our initial stop point, right? But it said where he stops. So if he went backwards left from that point, would it be negative 2t?
Not necessarily. In this problem it is. In this problem it is to the left. The question is asking, you want to be able to translate this into the problem you have. When is the object moving rightward? That is, wherever V is positive. Wherever V is positive, okay? In this case, you can look at the picture and tell me where V is positive, because we've drawn a picture. So for what t values is V positive? For what t values is V positive? What do you say? T greater than 2. And in our case, we have to stop at the 5. So t greater than 2, and stop at 5. Okay? Agreed? Okay. When is he moving left? All of the values in our interval. 0 to 2, not inclusive, right? We need to know when v of t is less than 0. When is it negative? 0 less than or equal to t less than 2.